Good afternoon, folks. Welcome to today's webinar. Thank you very much for joining us. The topic of today's webinar is Coding as a Playground, Exploring Early Childhood Coding with Professor Marina Bers. And I'm very excited to be joined today by Dr. Bers, who's going to be sharing her insights, her research, suggestions for implementing creative technology experiences in early childhood based on the research that she has done. So welcome, Dr. Bers.
Hi, welcome.
Hi. All right. So before we really get started with the webinar and hearing from Dr. Bers, I just wanted to introduce myself, take care of a little bit of housekeeping about the webinar. My name is Jason Ennis. I'm the Director of Curriculum, Training, and Product Management at KinderLab Robotics. We're the creators of the Kibo robot, and of course, Dr. Bers is our chief scientist, and she and her research team invented Kibo and did all of the research to design it and demonstrate its efficacy with young children. Dr. Bers is also the chair of the Elliott Pearson Department of Child Study and Human Development at Tufts University. So she wears many hats. So today's webinar, the flow is that we will, I'm going to introduce just a little bit of background about KinderLab and the Kibo robot so that you have that kind of model in mind as Dr. Bers talks about some of her research. And then we'll move right on to hearing from Dr. Bers about both her new edition of her book, Coding as a Playground, and also other research and projects that she and her team are involved in. During the course of the webinar, if you have questions for Dr. Bers, please enter them into the questions box in your GoToWebinar interface. Our moderation team, Christina, working behind the scenes, will be answering any questions that she can and then passing on questions to me and Dr. Bers to address near the end of the webinar. So in the last 15 or 20 minutes, it'll be all about your questions. So looking forward to that. So just type those into the questions box in the GoToWebinar control panel. Now, before we get started, we would just like to learn a little bit about you all, what your interests are in coming to this webinar. So if you wouldn't mind, I'm going to launch a little poll here for you to let us know what your role is in early childhood education. So that's going to pop up on your computer screen. You'll have the ability to click what your role is: a classroom teacher, a specialist, administration. Maybe you're involved in out of school time or informal education, or maybe you're here with kind of a research hat on or some other role. So just we'll spend another 20 seconds or so giving you time to just click and let us know what your role is, and then I will share that back to you. So thanks. Great. It looks like we have a lot of technology and literacy specialists here with us today, as well as classroom teachers, researchers, a nice mix of roles. So I'm just going to give 3 more seconds, and then I will close that poll, and I'm going to share those results back to you so you can see. As you see, we have a nice mix of perspectives here today. So thank you again for joining us for this webinar, and I'm really looking forward to hearing your questions based on those different perspectives on Dr. Bers's work. So thanks, welcome again. So just very briefly, I know you're here for Dr. Bers, and I'm just gonna get you oriented a little bit on who we are and how you can think about Kibo, the robot kit that our company makes and that Dr. Bers and her team invented. If you think about that sort of object to think with in Seymour Paperd's terms, it may help contextualize some of what Dr. Bers is sharing about her research. So our company, KinderLab Robotics, are the creators of the Kibo robot. We were founded in 2013 by Professor Bers and her co-founder, Mitch Rosenberg, who comes from a background in industrial robotics and entrepreneurship. Our company is focused just on the Kibo robot and the curriculum and professional development to support it. So Kibo is a robot and coding and engineering platform for early childhood. So it's really designed for kids 4 to 7 years old. It's entirely screen-free, so there's no app or computer element to it at all. The children create programs for Kibo using physical manipulatives. These physical manipulatives are very much like the wooden blocks that are familiar in an early childhood classroom. Each block represents one action for the robot to take, one command in its programming language. Children create a sequence of wooden blocks and then scan those blocks using a scanner built into the robot to give the robot the instructions that it's to follow. The robot also incorporates the ability to build and transform the robot with arts and crafts materials, familiar materials that may be on hand in the early childhood classroom. By building onto the robot, we can transform the robot into a vehicle or an animal or a character in a story. And this lets us support the idea that coding is a way for children to express themselves, to engage in imagination play, to engage in storytelling. So building onto the robot and engaging with the programming are all done using manipulatives and materials that are comfortable and familiar in the early childhood classroom. So Kibo is the result of research done by Dr. Bers and her team. They also developed Scratch Junior, which is an iPad-based coding and storytelling app for young children. The research into Scratch Junior showed them that they could also allow children to engage with these concepts in a much more concrete way through the use of robotics and physical manipulatives. And that's what led to the development of Kibo. Dr. Bers and her team continue to research in this area. Dr. Bers has published numerous books, both kind of textbooks as well as books for kind of working educators. And the book that we're here to talk about today, among other topics, is the second edition of her most recent book, Coding as a Playground. The book came out originally a few years ago, but Dr. Bers has updated it in a second edition. It includes new kind of case studies, new vignettes, as well as a stronger emphasis on the connections between coding and literacy and exploring that connection from several different angles. And I'd like to share that one of our attendees today will win a copy of the second edition in a raffle that we're holding. So I'm excited about that. But that will let us just get right into the questions with you, Dr. Bers. So I wonder if you would be willing to share a little bit about your goals behind this book, what you were trying to share with teachers and other readers in developing this book, and also in updating a second edition.
Yeah, so, well, first, it's really nice to be here. So it's good. And Jason, you can call me Marina. It's fine. So, when we design technologies, and that's kind of my job as a designer of learning technologies, the technologies are very attractive. So keyboard robot, it's really nice. And, of course, you see this little cute orange thing walking around and you can scan it and you can decorate it and it's very cute. Or we designed Scratch Junior, which is a free app, scratchjunior.org, that you can all explore for coding. And again, wow, that's so wonderful, it's great. But the technologies are fantastic, but technology and pedagogy are not the same thing. And so as much as I love designing technologies, and I consider that a very important part of my work, and that's what I was trained for, I feel the more and more we see the technologies out there, the more and more I notice how we need the pedagogy as there. So that the technology is used in a way that we believe is the best ways for it to be used in a classroom. And so while you can package Kibo in a box and send it out, it's very hard to package the pedagogy. So when I teach, or we do, when I teach at Tufts and students take my classes, or when we run the Early Childhood Technology Certificate Program at Tufts University, which is a one-year program, we are there to teach and to model. But when we are not there, how do we do it? And we have websites and we have video clips, but books, as much as we are in the 21st century, books are still one of the best ways to get our ideas across, because academic papers are very research-based, but books, we can write them in a way to tell stories. And so I feel that it was very, very important to tell different stories about how we make our classrooms into coding playgrounds. And the first coding playground, the first book came in 2018. So it's only 2 years ago, or almost 3 years ago. And it really went very, very fast. Usually we don't do second editions within 2 years in the world of early childhood education. But this was, so then I wasn't thinking of doing a second edition at all. So the publisher approached me and said, look, we've never seen this. It went really fast. We need to reprint anyway. Do you have anything new? So we should reprint a second edition. And so I said, yes, because we as researchers, we keep advancing all the time. So that's how the second edition came. But the idea is to really bring the pedagogical lens and the theoretical lens of how to use these coding technologies in playful approaches and developmentally appropriate approaches.
Okay, yeah, that makes a lot of sense, and that's something that I've been struck by with this book, is how effectively it blends the theoretical foundation that you use to develop the pedagogy to support teaching with these tools, blending that with these kind of practical how to use various tools to support these goals. So that's wonderful. And I know that you, one of the other developments alongside the second edition was you were looking for ways to support educators or even just interested readers of your book, to support them in either using the book in classes or supporting book groups. So you've created kind of a book guide with a discussion guide as well as sample activities. Can you talk a little bit more about that? And if you'd like, I can bring up the website and show it.
Yeah, you can bring the website, that'd be great. So basically, above all, I'm an educator, so I want my ideas to be out there in the world. So I felt that it would be, I was approached in the past by different groups that study the book, and they have the book groups about the ideas, and then they ask me to be a guest speaker or to, and I do as much as I can, but I cannot do a lot of it. So then I thought, well, how about create a book guide? And that will help people. And so if you go to the book guide and you'll see that there is information about the book, there's also a guide that has all the different chapters. So if you actually, the introduction has a watch and read section, and let's start with the introduction. So if you go and in the watch and read, you can see there's a little video of myself talking about the book. So I cannot be in every webinar, but you can see me there talking about the book. And then if you pull it up, then there are there's always a reflect section with questions to discuss. There's always a play section. We believe that we learn by doing, we learn by playing with different kinds of activities to play. And there's also always a section on take it further, which could be a video or could be readings. So if you choose, for example, chapter 1, you will see that there's a name of the chapter, and then it says it provides a synopsis of what that chapter says, then the questions to reflect, and then there is again activities to play and links. In this case, one of my favorite, how you can play with logo to honor Seymour Papert, right?
Absolutely.
And then there's always the take it further section with other videos and things. And so any chapter that you click, for example, you can click chapter 7, thinking about computational thinking. I know we did a webinar together a few months ago about computational thinking. It's the same structure. There's a read, there's a reflect, there's a play, and there's a take it further. And so that's it's a resource out there for people to use in their own courses, in their own teaching, or in their own discussions, even with parents. If you're an educator and you want to have discussions about what's the best uses of technology with children, this might help you create parent reading groups and things like that. So hopefully it's useful. And actually, if anyone in this webinar is gonna use it or are using it, I would love to hear feedback about it, because I put it out there and I'm not sure how it's been used. So it would be wonderful to hear from you if you're using it.
That's great. That's a wonderful suggestion. And I'm sure the audience of this webinar are just the kind of people who would find a book guide like this very useful to structure kind of their reactions to the book and sharing the book, like you say, with their communities or parents. So that's at the end of the webinar, I'll mention to folks, we have a contact slide where you'll have information on how to get in touch with Marina and with me. So if you have any follow-up questions, or you can share your experience with the book guide or with reading Coding as a Playground, Marina would love to hear that. So thank you. All right, I'm going to switch back to the slides and ask you now to touch on some of the themes that you address in your book and that I know have guided some of the research that you've done that led to tools like Kibo and to the pedagogy. A theme and a metaphor that you often return to is the idea of playground technology. So it's right there in the title of the book, Coding as a Playground. And I wonder if you could talk a little bit about what you mean by that metaphor, and then also maybe share some concrete examples for the teachers in the audience so that they can really think about what it means to engage in that kind of playground style activity in the classroom.
Yeah. So as you mentioned, I usually talk about, I like metaphors. And so the metaphor, I contrast the metaphor. We can only understand playgrounds contrasting them with playpens. And that's the metaphor, a playground versus a playpen. A playground is open-ended. It supports creativity, imagination, problem solving. It supports autonomy as well, and all dimensions of development. There's physical development, there is social development, there is a language development, there is emotional development, there's even moral development. Do I cut the line in the seesaw or I don't cut the line? And so it's very much open-ended and creative, where the playpen is very limited and it's safe. A playpen is very safe. If I need to go cook, I can go cook. My child is going to be okay, but it's limited. It's limited in terms of learning opportunities, in terms of creativity. It might be okay to teach one particular very discrete skill, but I need to be aware of that. So of course, when we think of coding and we think about introducing technology in the classroom, we want to have playground types of experiences. We also are realistic that sometimes we do need playpens because we're busy and we need games that kids can play on their own. But if we're going to have a playpen, we probably want to limit it to a couple of minutes, 10, 15 minutes, not long. If we have a playground, we can spend more time. And so in our research, we talk about the 6 C's of playground technologies. And those are behaviors that we can find in my neighborhood playground, as well as in a coding playground. And they are called C because they all start with the letter C. So there's content creation. Children can create, and they can create a sand castle, or they can create a keyboard robot that dances the hokey pokey, right? So it's content creation. There's creativity. All the sand castles on the sandbox are going to look very different, and all my keyboard dancing robots are going to look very different. There is a community building in the sense that you're not working alone. You're always playing and learning together with others, and you're sharing and you're proud and you're like, yeah, I did it. Look what I did. If you actually spend time in a playground, you will notice that children very often will go to their parents and say, hey, watch me, mommy, watch what I did. You are proud of what you did. You want to show off. So the same thing is in the coding playground. We want children to be proud of their projects, and we want to accommodate as teachers time for them to share in their projects. So we have a community building. We have choices of conduct. So I can make my own choices in the playground, in the neighborhood playground. I can choose to go on the seesaw. I can go up and down the monkey bars. I can come down the slide. I can just sit on a bench. I have, even though I'm 5 or I'm 4, I still have in my hands to choose my behaviors, and then I will have the consequences. If I go too fast on the swing, I might fall, right? And the same thing is in the coding playground. I have choices. I can share my materials, or I can not share and also assume consequences. I can use arts and crafts. I can become, for example, in the case of Kibo, I can become the scanner or I can be the builder, or I can become the coder. So there are always different pathways. So that's the choices of conduct. And there is a communication. That's the other C, a lot of communication, because we work with others, we talk. And so in this way, the coding playground becomes a social space, a space where social emotional learning also happens. It's not just a cognitive place. And I'm missing a C, communication, creativity, choice of conduct, content creation, collaboration, right. So we do things together, right? In the picture that you have right there, there's a grown up and a kid shaking, doing high five. But in playgrounds are not fun if you're alone. And the same we think about the coding playground. So the secret about the coding playground is not on the technology, it's on the teacher. And it's thinking how you set it up so children can really enjoy and play and have fun. And I would say if you're a little bit lost, look at your neighborhood playground and see how is your neighborhood playground set up and what kinds of things happen in that neighborhood playground. And those might be good guides for helping you set up a coding playground in your classroom.
Mm-hmm. Thank you. That makes a lot of sense. Of the guy using the sort of playground as an example. One thing that I was struck by, an example that you shared in the book, was sort of observing that when children are engaged in like a play-based creative experience, one attribute of that is often they don't want to stop. They don't want to be kind of interrupted with what they're doing. They're almost in that state of flow, and giving children an opportunity to experience that in the classroom. You shared an example of a child, Jamie, I think, who had developed a cleaning robot, and it struck me, building on Takibo, attempting to modify the front of it to more efficiently clean up the room, and that sort of cycle of invention and creativity was guided by a goal that Jamie took on, and that goal could be given by a teacher, but the methods that Jamie could choose were open-ended and up to her. And that example of sort of allowing the children to find their own implementation within kind of a goal struck me as a way to model some activities. Have you experienced that in thinking about the play part of the playground metaphor, and encouraging sort of a playful approach to technology? Are there specific kind of activities you could recommend?
Well, I think any activity that involves designing and coming up with ideas and coming up with prototypes for testing your ideas and refining them. So any activity that involves a design component will really work. Design meaning by starting by asking a question. So the example that I mentioned in the books, how can my robot help me clean the room? Or how can my robot scare squirrels that are eating my bulbs outside? Or how can my robot show that she's happy? So, we start with questions. And once you have a how question, then it's about teaching children how to go through a design process. So they get to brainstorm possible solutions, they get to prototype, try it out. It will not work. So how do you help them not give up and try again and develop strategies for fixing it and working with others for help? So it's not everything is dependent on the teacher, because when you start with individual children's questions, if you as a teacher believe that you are the only one that can answer your questions, you're setting up yourself for a lot of trouble, because you will not be able to answer 30 children's questions. So it's very important to set up a classroom environment where it's very clear that you are not the only expert. And so all of the questions can be directed to each other as well. And so, but the most important is starting with a question and engaging children in all the steps of the design process, finalizing with sharing what they have done. It's an opportunity to show gratitude to all those people who helped them. And it's also an opportunity to debug as a group. And we want to share the projects, even those the ones that do not work, because the message here is like, we are all engaged in this adventure of building, of making, of coding, of problem solving. and we don't all have enough time to reach a solution right now, but our process is as important as the product. So it's very important that every child in the classroom shares their final project, even if it doesn't work, with just how they could fix it to work.
Great, thank you. Yeah, I love that idea of the how question, framing the sort of kicking off the engineering design process and the creativity. All right, thank you. Yeah, that framing is really a helpful way, I think, for teachers to think about how to encourage these kinds of experiences. So pivoting a little bit to a different way of thinking about some of these concepts. One of the big areas of the book that you expanded in the second edition relates to these connections between coding and literacy. And I know that you've talked about sort of the value of coding. One of the reasons that we want to teach children to code is to give them new tools for self-expression. So there's that metaphor that I know that you've shared, but it also, I see that in the book, you're making many more kind of literal connections to literacy as well, including this idea of adapting the concepts around stages of literacy acquisition and using that as a way to think about how children learn concepts like coding. Can you talk a little bit about that and the connections that you've found between language acquisition and language use and coding education?
Yeah, so maybe, Jason, you want to go back one slide?
Sure.
Yeah, because I want to talk about the connections without mixing with the slides. Yeah, so
Absolutely.
For us, if you think of literacy in terms of the big picture of what literacy is, literacy, and I'm talking about alphabetical literacy, but any kind, it's also visual literacy, right? Is you learn, but let's focus on alphabetical literacy. It's learning that there is a system of representation, that's an alphabet, right? That it's limited, that can be combined into a grammar and a syntax to convey meaning, right? And with 20 something letters in English and 20 something others in Spanish, you have all the way to from Shakespeare to children's books, right? And it's the same system. It's just that the way it was used and it was combined. So the power is not in the system. The power is in the person using the system to create meaning. And so it's the same in this sense. It's the same when we're thinking about a programming language. A programming language is a language, right? It's a limited system that abstracts, and you can create anything you want with it. Of course, it has limitations, but you can learn those limitations and work around. And the goal of literacy is not just to code and decode. That is the basic, right? We assume that by second or third grade, everyone should know how to code and decode. But a true literate person is someone who can create meaning, who can combine this coding and decoding to really express herself, to communicate, and to enter into the social world. So the way we understand coding is similar. Meaning, if I'm able to use Kibo just to do one thing, right? Put only move forward blocks and that's it, then I might be able to code and decode the basics of Kibo, but I will not be able to use it to really express myself. If I can use those same forward blocks to create a dance, I'm using very simple blocks, right? Not the most sophisticated blocks, but I can create a dance and weight and different beats, right? Then I understand that through my language I can communicate or I can express myself. And I'm from Argentina, so if I can make a tango dance, it will be even better. So I think when we think of coding as literacy, we look at it in two ways. We look at it as problem solving is a step towards expression and communication. Problem solving is not the end of itself. And sometimes when we talk about STEM, science, technology, engineering, and math, there's a lot of wonderful focus on problem solving, but it looks like that's the end goal, as if all we want in life to problem solve. Well, some people do, but others don't. And so when we think about coding as a literacy, we're saying problem solving is at the service of expression, just like what we do when we do reading and writing. We all forgot because it was so long ago. But when we were learning how to read and write, we were doing a lot of problem solving. It's just that it was so behind that we forgot about it. So now we associate literacy with expression, right? But there was problem solving. And in coding, it's the same. Our goal is really to support expression. And that's goal number one. The second goal is literacy plays a very important role in society, right? Those who know how to read and write are those who can be in charge of their destiny, those who can vote, those that have a civic voice. And we know, I love to bring the Brazilian educator, Paulo Freire, which, you know, back in the 60s in Brazil, and he wrote about the pedagogy of the oppressed. But basically what he was writing is, if you want to change a country, you need to teach people how to read and write. Because if they know how to read and write, they'll be able to vote, they will be able to be educated, they'll be able to express their voices. And so he spent all of this effort doing literacy education campaigns. And he wasn't the only one. You know, I'm using him, but it was all over the world. And so the question is, so we know that literacy has been associated with thinking, with a civic voice for a long time. Well, is it the same today? If we think about the literacy of today, which is coding literacy, those of us who understand how algorithms works will be able to understand why Facebook or where some news media choose to give us some information and not others. We'll be able to understand the bias built into algorithms. But those of us who don't know even what an algorithm is, we just are going to be the illiterate of the future. And we do really, and that worries me. So that's the second sense of literacy. One is very literal, and the other one is more a bigger picture. And the third one, and this is the last one, is if we're working in early childhood, even though I love technology, a child in early childhood needs to learn the basics. And one of the basics is learning how to read and write. And we are teachers and we have limited time. So how do we do it all? Well, we have this gift, right? Which is that programming languages and natural languages, because they're both systems, abstract systems, symbolic systems, we can teach the two of them in conversation with each other. So as we're teaching the alphabetical literacy ways of thinking, we can be teaching about coding ways of thinking, because some of those, and we've done a lot of research showing how this can be done. And even more, we have developed a curriculum and that's called Coding as Another Language. And there is a new, actually, that's the one that we have in the past for Kibo, coding curriculum for emergent readers and for readers that you can follow. And then I put a link there to the organizer with a new version of it, which is in a website for Kibo. And Jason, I don't even know if you know that, but we've been very busy on our website, in my lab, piloting this. We've piloted in Norfolk, Virginia, and now we're working with Head Start programs in St. Louis, Missouri, with pre-kindergarten. And I don't know if you can see there, or
I
if you
just
want to
shared that.
yeah. So
yeah, thank you. I shared the link that you gave to the chat.
So those are all free, and you can take a look. And it's very organized around this coding as literacy approach.
Great, thank you for sharing that. Yeah, that's that idea of sort of linking literacy acquisition and coding sort of sets the stage for another question that I know folks have when we get down to sort of brass tacks about how coding might fit into the day in an early childhood classroom. I wonder if you have any recommendations about kind of using coding and that idea of children expressing and exploring things that are interesting to them, using that to support kind of cross-curricular learning. Can you share any examples of maybe an activity that a teacher might implement that supports putting coding into a context elsewhere in the day?
We, in a lot of our curriculum, we use books. So we look at books and then we recreate the stories through different endings with you know. So for example, if you go to the CAL curriculum, Coding as Another Language, you'll see that we use books such as this one, where we look at the history of computer scientists and we recreate aspects of their lives. I would say that, you know, if you start with a question, naturally you will end up with a cross-curricular learning, because questions are not designed to be cut into artificial curriculum areas. Questions are really cross-curricular and they're project-based. And so if you think about the way to start is to start thinking about projects, any project you want. You can work with, you can look at the animals in the jungle. You can look at dances around the world. You can look at what's the best route for a snowplow to work in my neighborhood. You can work around the community. Any time you have a question and a project, you are going to bring cross-curricular. Because Kibo is about sequencing, because in order to program, you need sequencing, and sequencing is at the basics of literacy and math. You need to sequence, then you are going to have sequencing. And if you count steps, you count Kibo steps, and you do predictions, you are going to get into the realm of math. And if you include stories, you are getting into literacy, also into oral presentations. Every time we have the sharing with the community, you are reinforcing oral language as well. If you are drawing, you're bringing the arts. If you're using other materials like cardboard, like this little piglet here. So, and physical movement, because you can be dancing around your program, you can be moving around. So I would say the question is how we cannot incorporate it, because I will challenge you, it's very, very hard to find projects that are not cross-curricular.
Yeah, and that's I know exactly what you mean about the way that you know, an open question can draw in things that we think of as totally separate curricular domains. And I know that with early childhood education, we want computer science and coding to be kind of embedded in these more holistic activities. So that makes a lot of sense. You mentioned sequencing just now, and that one thing I wanted to make sure we touched on briefly before we open it up to questions from the audience is just this notion of computational thinking, because I know that that can be a way of thinking about aspects of child development that we support through these kinds of experiences. And it's maybe another pillar like that kind of cross-curricular, open-ended how question way of thinking about activities. Maybe you could talk a little bit about how we can support these things like sequencing skills through these activities.
Yeah. So computational thinking is a fancy word that now it's you know, people like to use. But if we think about executive functions, which is something that as early childhood educators maybe we're very familiar with, you know, there's a lot of overlap. So when you are doing, when you're engaging in computational thinking, what you're doing is you are breaking a big problem into small pieces. You are learning how to combine them. You are learning how to apply different strategies. You are learning how to remix. You are learning how to think in terms of abstraction. You are learning how to create modules. So it's a lot. We're learning how to manage your time. So it's very, very much aligned to learning how to grow up in a way that functions in society. And of course, the best way to get a computational thinking is by coding. So tools such as Kibo or Scratch Junior or Python or C if you're a grown up, you know, that's where you really exercise your computational thinking. But also there are a lot of unplugged games and unplugged activities that will help us think in terms of computational ways. And that really means organized, logical, abstract thinking. That's what we mean. So for example, if I'm gonna try a solution for something, I'm not just gonna do random tries. I'm gonna have a strategy for how to go about developing my solution.
Right. And breaking, I know with sort of breaking down a larger problem into steps is something that we, you know, at this age group is an important part of pretty much every activity that they engage in. And that's a key sort of element of computational thinking design as well.
And even in this age group, Jason, when we have to go outside recess and it's winter, right? And we have to get dressed. So do we put our boots first or our snow pants first? You know, we teach kids the order in how we dress to go outside to be more efficient. Of course, we put the pants first and then the boots, but that's something that's not intuitive. Well, you know, that's breaking up a larger program, how to get dressed in the winter to play in the snow, into very small chunks. The same thing is cooking a recipe or, you know, many things.
Absolutely. All right, well, I had one other sort of question that I wanted to ask you to share a little bit about, which was on social emotional learning. You brought up earlier, we don't need to linger on this slide because I know that you explained the concept of the 6 C's and the ways we can support development of kind of children's character through these playground technology experiences. I will just say that the framework that you've developed here, which you articulated more in one of your earlier works, but this is included in Coding as a Playground. So you can, if you're a teacher and you're interested in how we can directly connect these different attributes of like a creative technology activity, connect those to the development of these positive traits and attributes in the children, that is addressed in the book. But I don't know if you wanted to, I know that social emotional learning and kind of development of children's capability to like persevere, to work together, to feel comfortable sharing challenges, that those are all aspects of child development that teachers are interested in, whether they're doing coding or not. So I wonder if you wanted to comment a little more about that.
So actually, this is something that I've been spending the last 2 years really working in a lot of depth. And I'm gonna give you the news, but next spring, 2022, I have a new book that MIT Press is gonna be publishing that's called Beyond Coding: How Children Learn Human Values Through Computer Programming. And that's the new book. And you know, at the time too, when times get closer, it's already in press, but it's going to take a year until it's out. But so I've been thinking a lot because, you know, a playground, it's a place where social emotional issues are out there, right? And same is with coding, because every time you have a problem, you have to learn how to deal with your problem. And coding is about problem solving. So it's not just a cognitive matter. It involves the social and it involves the emotional, because that's what problems do, right? We all feel that. Grown-up problems as well as children problems, right? And so if we are saying that we are setting up an environment that it's all about problem solving, well, let's be serious about that. Problem solving is not just limited to how to make my keyboard move forward, because if my keyboard doesn't go forward, and I've been trying really hard, I have a bigger problem, which is how do I stop having a tantrum if I'm 5, right? Or how do I forgive myself for trying and not be able to do it? Or how do I persist and try again? And so I think we haven't paid enough attention of the social emotional aspects that can be played in the coding playground. And as you mentioned before, when we teach the whole child, especially in early childhood. And so I feel that we have been kind of missing opportunities in the coding playground to really explore these social emotional aspects of learning. And in my new book, you will see that I talk about a palette of virtues. I use the word virtues or values, which is values worth right now, that have to do with character development. And I present 10 of them, such as persistence, gratitude, curiosity, and open-mindedness. I don't want to go too much into this right now, but so this palette of values, of this palette of virtues, are things that I want to promote in my coding playground as well. And I can mix them and matches. That's why I use the metaphor of a palette, just like a color, like a painter, right? An artist, you have your colors, but you mix and match them. And every painting is going to have its own scale and its own feel. So it's the same with my own classroom. Is going to have my own learning culture, my own rituals, my own values. However, if we are coding, we are all assuming that we're basically working with curiosity, with persistence. So there are some universals to it that, of course, can get color and painted in different ways according to the particulars of the classroom. And those have to do with cultures of learning and cultures of innovation. So what are the values and what are the social emotional aspects involved in cultures of innovation? And coding playgrounds are cultures of innovation, are cultures where I create something new. I start with a question. And if I have a question, that means I'm going to innovate. I'm not just repeating something that was already done and I was already created.
Right. That's very exciting. I know that our audience will be looking forward to that book, and it sounds like a really great kind of elaboration of the framework that you started to explore with the
Yeah.
6 Cs. I mean,
Yeah,
go on.
and let me say something else. What happened is that I realized that I was always talking about behaviors. Like in the playground, you communicate, you collaborate, you build community, you create content, you are creative, and you have choices of conduct. But then I realized that behaviors can be good or can be bad, right? So it's really the values, the intention behind the behavior. So I can communicate in positive ways or in negative ways. I can collaborate to create or to destroy it. I can build communities for hate or build communities for peace. And so then I realized that the behaviors need to be grounded on something else, a little bit more deep, a little bit more grounded on identity and shared values. And that's how this notion of the palette of virtues came about, because behaviors
That's
is not
great.
enough.
Okay. Well, that actually brings us pretty directly to one of the first questions that we've received. So Christina has been taking in questions from the audience, and one of them, I think we could, this in a way addresses what you're saying about kind of creating a certain community or a certain set of values within the classroom. But I have a feeling that the person who asked the question is also probably thinking even more tactically too. And the question was really about, what do you think are kind of the barriers to implementing these kinds of activities in early childhood classrooms full time? And whether that's, you know, access to these tools is one thing, but another way of thinking about that question is creating these kinds of mindsets, these kinds of the open space to implement a kind of how question, like you're saying, as an activity. So what do you think are barriers, and what are some ways teachers can overcome those barriers if they want to implement these kinds of
Yeah,
activities?
so one of the biggest barriers is time. And so when we have our chunks of our curriculum compartmentalized in 30-minute time chunks, that's very hard, because to set up the keyboards, it takes time, to clean up, it takes time, and then to explore takes time. You don't go to playground for half hour, right? You usually stay longer at the playground. And a coding playground is a place where children want to stay. It's a place that they want to, and so I think the way those chunks of times are set up, and so I would say, if possible, to reorganize how your blocks of times are organized, that would be helpful. The other thing is, so it's time in the classroom and also time outside the classroom as a teacher. You know, some early childhood teachers are not, you're simply not compensated for the time outside of the classroom. And a big success is if you're organized by the time you arrive to the classroom. So when you work with robotics and in general with technology, you need time to think about how to prepare the materials and how you're going to present them to the children and how you're going to sort them, and you have the batteries in place, and that takes time. And I would say that as early childhood teachers, we need to do, or administrators, we need to do a good job explaining how that takes time. And so time is not a barrier. I would say time is one of the biggest barriers, more than the access to the technology. Because access to technology, I've seen environments where they share the technology and they pass it from class to classroom. But time, it's, if you cannot buy time. That's the truth. You can buy keyboards, but not time.
Right, good point. I know that you spent some time in developing the 6 Cs framework on creating kind of instruments for assessing whether a classroom or a classroom experience supported the behaviors and the assets. Has that helped with educators that you've worked with? Has that helped then make the case to administration, for example, about the value of these kinds of experiences? Is that a focus you have in the values work you're doing now?
Yeah, so in the values work, we're working and we are redoing right now the PTD checklist. So the PTD checklist is basically a checklist that allows you to see if the way you set up your environment is conducive to a coding playground. Because sometimes it might be as simple as removing some of the tables and the chairs so you have more floor space, or removing something from the walls because it's too crowded and you want to have a room on the walls to post the kids' pictures or the kids' projects, or the design process. Sometimes it's more complicated in terms of how do you arrange, do you put all the sensors together? Do you mix the sensors? Do you put all the colors, blocks in the same boxes? So how you organize your materials. And so the PTD checklist is supposed to help you assess. We are, a student of mine right now is reworking that, and we're gonna try it out, the new version, but the old version still works. We also have a game that's called PTD cards that you can find it for free on our website, and play with it. And it helps you think about the kinds of technologies you can bring into your classroom and how to reorganize your classroom. So
Great.
I would say that that's the main, yeah.
Yeah, that's very helpful, because I know that you know, for teachers where they are struggling with time, part of that is, you know, getting that sort of shared vision between administration and the teachers. I guess we had another question that relates both to this and also to an earlier slide that was about literacy, which we moved past, but I'll bring it back up. So this teacher was asking about as far as barriers to implementation go. Another one is really teachers who don't have a lot of experience with these kinds of tools or with kind of technology experiences themselves. And in your work with thinking about these kind of stages of acquisition, have you thought about the role of kind of teachers learning these tools kind of along with the students? I know that the Kibo curriculum, both from KinderLab and the curriculum from DevTech, is very conscious about introducing these concepts in a progressive way. But has that, have you thought at all about how these stages kind of correlate with the teacher's experience learning in these tools?
So part of the research we're doing right now with Scratch Junior, not with Kibo, but it's just, you know, what we're doing is that we're looking at if the coding stages, you know, these stages of literacy, if there is a relationship between the coding stages achieved by children in a classroom and the coding stage achieved by teachers in a professional development.
Oh, great.
And so you know, we are working with thousands and thousands of teachers and children right now with Scratch Junior. But in the past, some previous work, the pilot work that we did, which is interesting, show no relationship. Which is interesting, where again, this isn't, it's only pilot data, so don't quote me yet, you know, once we have the full data. But because children, what we notice is children were able to advance stages fast, and some teachers were not, and their children still learn, right? And it has to do with sometimes adults, we bring our own limitations and we're worried of trying new things, while children are not. And so children were able to play new things. Again, I don't know if this is scalable, because this is just from pilot data.
But it
but
does
that's
sound
one
like
of the research questions right now. You know, what is the relationship between teachers' own professional development and children attaining of different coding stages?
That makes me think of the role of the teacher sort of as, you know, the preparer of the experience, the creator of kind of the framework that children can engage in to learn by doing. In a sense, it doesn't matter if the teacher, if the child progresses beyond the teacher in their coding skills. That kind of fits with the educational model that
and
you
that's
have
why
there.
and that's why it's so important to set up an environment where the teacher is not the only one that knows, that the teacher from the beginning says, we're learning all together and we're going to share with each other our knowledge, because then you're setting the stage for children who learn things that you might not have learned to actually show off and teach, become teachers to the rest of the class. And that happens a lot. And that's why we have this, what we call technology circles, right? Where we provide spaces for people to share.
Absolutely. That actually brings us to the last question that we've had sent in, which relates to this commenter observed that there feels like there's a Montessori kind of influence in both the materials and the way of thinking about education. And I know that Montessori and Reggio and these philosophies of kind of experiential learning did inform some of the design, but are you, do you have sort of, can you talk a bit about other kind of educational styles or philosophies that you've drawn on in developing?
Yeah, so we look, you know, at every time that there was in early childhood learning manipulatives, and we started with Froebel, you know, in the 1800s, and Montessori, and you continue the list, right? Every time that educators thought about the role of a physical manipulative to understand abstract concepts, that's something that we were inspired by. It's just that our manipulatives in the 21st century are manipulatives that involve ideas about technology, and maybe in the 1800s they were about color and shape, right? But today they are dynamic. There's ideas of sensors, and there's ideas of actuators, right? And so you know, there's a lot of wonderful philosophy. I would say almost every early childhood philosophy that's out there, from Vygotskian to Piagetian. So even when they're very different, we incorporate. We're not, yeah, we like to share.
Yeah.
I mean, we've done a lot of work with Montessori schools, and Montessoris tend to be more strict, and they found ways to adapt our approach to their Montessori style.
Putting the sort of control in the children's hands, and through those manipulatives, the parts of the robot, at least with Kibo, the parts of the robot that the children are responsible for attaching to give the robot its functions, has always, that I can see your connection using manipulatives as kind of a guiding principle for all of this. So I wanted to, we're coming just up in the last couple of minutes, and I wanted to make sure that folks had, in addition to some of the resources that Marina has shared, the coding as another language curriculum that we shared the link to, we'll share some more of these materials with you via links in a follow-up email that goes out to make sure you have those links. But in addition, there's a resource I wanted to make available to you right now. You can download it from the handouts tab in your GoToWebinar interface, and it's a PDF of ready to run lesson plans with Kibo that are based on the idea of integration across different curricular areas. So they take this idea of navigating Kibo in a physical space in the classroom and show models of how to integrate that with math, literacy, social studies. So these are expressions of some of the concepts that Dr. Bers was sharing within the book. So I wanted to, just say thank you so much, Marina, for sharing your time with us, sharing your expertise, and for the book that you're working on, as well as the new one. Thank you for the sneak peek about coding and values. We're really looking forward to that book. I encourage all of our attendees to reach out to me if you have any questions, and Dr. Bers was kind enough to share her contact info here. So if you'd like to reach out to ask more about these topics, or to share your experience with using the book guide, for example, that supports coding as a playground, as Marina said, she'd love to hear about that. So any final words from you, Marina?
No, I think that's great. I just put it there, Jason, for you. We mentioned the PTD cards and the PTD checklists. So I just put the link there so you can share with all, so you can find it, you can download it. And that's the information you have there is my KinderLab email. You can also reach me at my Tufts email, marina.bers@tufts.edu. But anyway, so it's fantastic, and I'm really looking forward to hear how people are using the guidebook. If you are using it, that would be great.
Excellent. All right. Well, thank you again, folks, and thank you, Marina, for joining us. We appreciated your time, and we appreciate all of you who came to see the webinar. So please be in touch, and we'll hope we see you again at our next webinar, which will be at the end of March about Kibo in makerspaces. So keep an eye out for that. All right. Thank you all. Have a good afternoon. Well, I made the connection between the together, so I didn't on how